I recently found out that I listen to a lot of music. But if there's one thing that's alike in all of these different genres, it's the way that it's created and produced. Well, at least on a mathematical scale. You see, every piece of music is made up of sound waves, where the x-axis is time and the y-axis is amplitude. So if I whip out my 3rd grade recorder skills, it's going to make multiple different pitches, and there's going to be a change in amplitude waves as a function of time. This creates oscillations, where different notes have different oscillations. So I could play the note D, or I could play the note A. When both A and D are played together, they create a combined waveform with this combined amplitude versus time graph. So this is actually how sounds are created. But this is super important in music production, which is where Fourier Transform comes in. This equation might look scary, but it's basically just a mathematical domain change, where the x-axis of the sound waves are going to change from time to frequency. We'll consider the change in the recorder's sound waves. On the right, we have the time and amplitude graph, which is the original sound wave. Each of these new colored waves represents a different chord with a unique frequency of the recorder. So by graphing the amplitude with respect to each note's frequency instead of time, we now get the new green peak graph, which is a Fourier transformed graph. But we are going to start from scratch, which means we're starting with a complex plane and Euler's formula. So just forget that. If you take e to the power of some number and multiply it by I, you'll land on a point. And if you land on that point, you'll walk that number of units around the circle that has a radius of 1 counterclockwise by starting on the right. So let's say that you wanted to rotate at a rate of 1 cycle per second. This is e to the power of 6.28 times I times t, where t represents the amount of time that has elapsed. But let's say that you wanted to look at it from a different speed instead of 1 cycle per second. Well, in that case, you could just multiply t by f, which is frequency. If you want to move at a clockwise direction for Fourier transform, we add a negative sign. Then you multiply the entire exponent expression by x at t, and you'll get a rotating complex vector, which essentially represents that wave smushed into a circle. The goal of Fourier is basically tracking how the center of that circle is going to change over time. So to sample this, we can approximate it tons of times from the original signal, and then we can take the average. And this is where we get the discrete Fourier transform formula. But to make it much simpler, we can just take the integral of this. And boom, you have just created that really complex formula. So really, x at t is like the input signal. It's the recorder's first sound wave. But then we're transforming it into x at f. And again, Fourier transform is really just a mathematical domain change from time to frequency. Wait, so how is this used in music production? Well, let's say that you have a recording and you have a super high-pitched annoying sound. All you have to do is actually just take the Fourier transform of that signal, and whatever that high-pitched sound is will just show as a super high spike in amplitude. So you smush it down. So whether you're an experienced musician yourself, or are someone who just loves listening to music on Spotify, you can now use this scary equation to explain how music is produced